application of remote sensing and how it can be applied to see geomorphology. As you guys remember from our previous discussion, we discussed about the application of aerial photographs, and as the advent of remote sensing is actually we use the electromagnetic spectrum of the energy, and we just record the energy levels, and we also can do it with several windows. And mainly, as you guys know, due to the advent of satellite imagery, satellites are widely used to remotely sense various objects and can give us very valuable information that can be used later on for different studies. And especially as we are doing this for geomorphology, we will consider most of the geomorphological applications of it. Some of these satellites that are used for remote sensing, they are also equipped with a visible camera, just like the camera that, but it has much better resolution, and it also captures the black and white and color images of different objects. However, the main theme behind the remote sensing is the electromagnetic energy, and after it interacts with different matter, it can be recorded with the sensor, and then the recorded can be seen in the form of an image or a photograph. uh, this is almost you can say it's the similar way how we used to do the air photographs. Now we are using this for remote sensing, and remote sensing is actually a big subject in itself, and in some universities you can also do masters and PhD in remote sensing, and it is a very wide subject and it has wider applications. Data from the remote sensing can be recorded in near infrared and other optical windows, and some of them they can be recorded in multispectral scanners. Some of them are thermal scanner. As you guys know, electromagnetic energy, it has a complete window of radiations or energies, and we can select some of these energies, and based on that we can use the data for capturing various features or matters or materials on earth. However, there are some active microwave sensors that record data from microwave region of spectrum and have the advantage of recording day and night data as well as through clouds. Okay, sorry for the disruption. We continue. So there are different windows in remote sensing that are used for capturing the data and recording the data. And some of them they can record the data at day, and some of them that can record the data at day and night. It is very useful for recording terrain information by various sensors. And terrain is, you know, the morphology of the earth, like the rivers, the streams, and the hilly areas that are present. And this data can actively be used to. There are many advantages of using remote sensing data. As you guys know, it is recorded by the satellites, And these satellites sometimes they are geostationary. They are stationary to a point on planet Earth. However, some of them they are moving as the Earth is moving with the speed, the same speed as the Earth moves. Satellites revisit the same site at regular intervals of time, which varies depending upon the orbit height and inclination. That's why remote sensing data can also be used dynamically. Like, for example, if you photograph the same place like multiple times in a year, so you can compare actually, like if the river has changed its course of or there has been an earthquake or there has been a movement on the earth, so it can also be recorded as a result of that. There are some specific advantages of satellite images for deriving information on ground features, such as like land use. Similarly, like for example, if you want to do the planning of a city, you can also use a satellite image. And like for example, we can take example of Sargodha. You can take an image of Sargodha city 10 years ago, and after 10 years, you can see how much that city has developed. It has wider applications in city regional planning and other areas. There are different heights of these satellites, and there are different durations of capturing photographs. Some have doing photographs for like 22 days. Some have more days interval. Uh, These interval has been selected because over shorter period of time there hasn't been any changes along the rivers or along the landslides or some other features. That's why we need to have some gap, so that if there is some feature that has developed over the time, it can be detected, and it can be used for the benefit. Some of these satellites, they have multi-channel, so they can use different colors to highlight various features. Multi-spectral capabilities of remote sensing is that sometimes there are more than one sensor that is attached to a satellite, and those sensors are used to capture information. Microwave recording requires special efforts, and usually such data satellites are exclusive. The advantage in multispectral capabilities that certain bands or a combination of bands provide better contrast for image interpretation than other bands. So it is just the combination, the better combination, the right combination of satellites that is used for understanding an area. And during when you study remote sensing, you can also study and also analyze the understanding behind, that is the idea behind, like why we use certain bands, why we use certain sensors. Or it is all when you go to study remote sensing in detail, you will learn all the satellites, all the spectral capabilities, and then you will understand, okay, I will use the Iconos image, or I will use the Landsat image, or I will use the XYZ satellite, or it depends on your capabilities and understanding and your need, and also the height of the satellite as well. The interpreter has to be knowledgeable to choose a particular sensor data depending upon the specific application. So you need to have a background study of that particular area. While digital analysis is faster and appropriate in identification and delineation of crops and land use, they can be used for crop identification. Like for example, if you are in agriculture sciences, or if you are in geosciences, so it depends what field you are doing. If you are trying to study the soil conditions or the soil profile of particular area, there are different type of tones, textures, sizes, shapes, reliefs, drainage, slope, and land use, and association of features that is linked with the remote sensing satellites. So four phases of image interpretation. There are detection, recognition, and identification, analysis and classification of observable features in terms of landforms and genesis. It depends which phase you are. Some of the remote sensors, they work on detection. Some of them, they work for the recognition and identification. Some work on analysis. They compare different satellite images, and then they try to understand what is the difference between that. Then they come for the classification. Like for example, if you want to classify the satellite based images, and then you want to classify what type of streams are there, is there any braided stream, is there any meandering stream, oh, it is linked to that. A good reference level to the subject plus a formal training of interpretation are essential to derive maximum information from image. That's why I suggest you guys try to surf the internet. आप internet पे जाएं. There are many courses available free of cost, and you can try Coursera or EDX. These are two websites that have a lot of courses. So you can also do, if you have time, if you want to manage your time during this difficult period, you can also go for some of these courses on this website. Some of them, they are available free of cost. If you don't want to take certificate, you can try all their modules and you can learn for yourself. Here we have a satellite image of an area of Dune Valley, and you can see the surroundings. You can see the contrast in different colors, the sands and the other sediments, or maybe these are different rock types that are colored differently. And then the significant feature of this image you can see is the relief and the origination of streams, that you can see that there is a stream that is coming in and then going like this and then going like this, so you can understand the meandering and you can see the shape. And the quality of the image is very high as compared to the aerial photographs. Aerial photographs were used time before, and now most of the geomorphologists, they use satellite images to understand. Here comes another feature, that is the ArcGIS software. So that's why I always ask you to make an account on Esri. Esri पे जाएं, ESRI पे जाएं आप, and you can make your account free. And there are many free courses available on that for ArcGIS. You can start learning step by step. I can also send you a link. आपको मैं link भी भेज दूँगा. You can install ArcGIS software in your computers and you can start working. Don't go for complicated part, just start bit by bit, just start small and then try to make it, because GIS software is will open many options for you for your future job. As I mentioned, aerial photographs have been used historically, and they were just like the mother of the remote sensing, and especially during the World War II, and especially in Pakistan, there was Hunting Survey Corporation in Balochistan area, जिन्होंने पाकिस्तान का बहुत ज़्यादा geological mapping की थी. There was a corporation at that time in 1950s to 60s, and there were those guys, they also use satellite images or aerial photographs, because at that time we didn't advance in remote sensing, so they just used the aerial photographs, incorporate different features, and then they made the geological map of that particular area based on those photographs. There is some thing related to the scale. Aerial photographs, as you see, can be 1:10,000 and 1:50,000, and they can be it depends. Like if you are interested to study more details, then it's better you go for 1:10,000. If you want to just see the regional phenomena, you are not interested in bits and bits, small details, then you go for 1:50,000. Okay, so each one of it is equal to like 1 inch